Hello viewers, this is An American Thinks back with a brand new theory video for A Song of Ice and Fire. And this time, our topic will be something that has been one of my least favorite aspects about A Song of Ice and Fire, ever since the first time I picked up a Game of Thrones about a decade ago and looked at a map of Westeros. And that is the God's Eye. Now, this may strike you as odd, since the God's Eye is merely a lake, and admittedly it's an unusual thing to dislike, so let me explain. I spent all my formative years growing up in Minnesota. Officially, Minnesota is called the North Star State, but unofficially Minnesota is called the Land of 10,000 Lakes, which is a little misleading because Minnesota has upwards of 15,000 lakes. The house I grew up in had a lake across the street from our front yard and another lake off our backyard, and to be honest, having lakefront property never really seemed that special to me because just about everyone we knew had one. So, you might imagine being in and around lakes was a major part of a healthy Minnesota childhood. I pretty much spent my youth playing hockey, watching Mystery Science Theater, and purifying myself in the waters of Lake Minnetonka. The reason I'm bothering with all this reminiscing is to convey the point that I've been around an awful lot of lakes, and I've never seen a lake that looks like the God's Eye, with an island right smack in the middle of the lake. This type of thing just doesn't happen. If instead of a water feature you think of a lake as more of a geographic feature, a lake is really a valley or some kind of low-lying geographic area that happens to be filled with water. And the same geographic forces that cause this low-lying area generally preclude the presence of a sudden uprise of land right in the middle of the lake. It just doesn't happen. So the God's Eye has always struck me as a rather whimsical part of a story that is otherwise characterized by harsh realism. For me, it's at best an annoyance, and at worst it's a challenge to my suspension of disbelief. This is particularly true if you consider the size of the lake. If you compare the God's Eye with the Wall, which is generally said to be around 300 miles long, then the God's Eye is probably at least 100 miles across, give or take. It's easily the largest lake in Westeros, which is a continent notably bereft of lakes. So this isn't like some little pond that happens to have a little island in the middle of it. This is a major geographic feature. So I have to trust that if George R. R. Martin is as intelligent as he seems to be, and he's writing the story as intelligently and intentionally as he seems to write, then he didn't just sit down one afternoon in a fit of fancy and draw a map of Westeros like some Bob Ross painting. If the world of Ice and Fire is a carefully constructed world, then the God's Eye isn't some happy little accident. It was put there intentionally and for an explainable reason. So, if I fast forward the story of my life a little bit, my family moved from Minnesota to Oregon, and I visited the only lake I've personally seen that's anything like the God's Eye. In southern Oregon, in the Cascade Mountain Range, is a mountain called Mount Mazama. Over 7,000 years ago, Mount Mazama blew up. It turned into a pretty significant volcano, and when it finally ended, the top of the mountain had a huge crater. That crater filled with water from rainfall and from snow, and it is now known as Crater Lake. And at 1,949 feet deep, it is the deepest lake in the United States. Now, over the next 100 years, there were a few smaller eruptions from the mountain, none of which came close to the size of the original eruption, but they did form cinder cones, one of which is tall enough to stick out of the lake as an island, which is called Wizard Island because it looks a bit like a wizard's hat sticking up out of the water. The area is now a national park, and if you're ever in Oregon and you can make the trip, Crater Lake is really worth seeing. I mean, it's the deepest lake in the country, and it's inside a volcano. If that doesn't get you excited, then I don't know how to help you. Now, Crater Lake isn't an exact analog for the God's Eye. For one, the island in the lake is fairly close to the shore rather than sitting out in the middle of the lake like the Isle of Faces. Of course, this could easily be explained away as happenstance. There are, in fact, several cinder cones that are submerged under Crater Lake. It just so happened that the one tall enough to stick out of the water was near the shore. It could have just as easily been one of the more central cinder cones that ended up being the island, and then the analog would be more accurate. But a second critique is that Crater Lake is far smaller than the God's Eye. It's about 6 miles across, nowhere near the 100 or so miles of the God's Eye. Of course, there are supercalderas much bigger than Mount Mazama and approaching the size of the God's Eye, so maybe if the God's Eye were some former supercaldera, and maybe if that supercaldera blew up, filled with water, and then had a cinder cone develop in the middle of the lake, then we'd have an explanation. But if that weren't already a lot of ifs, I have another problem with this theory. As I said before, Mount Mazama is located in the Cascade Mountain Range, and this range is known to have volcanic mountains, including Mount Shasta in California, the Three Sisters and Mount Hood in Oregon, Mount Adams, Mount Rainier, and most famously, Mount St. Helens in Washington. That's a volcanic range spanning several states. So finding a volcanic crater in this range is really no big surprise, since there's precedent for it. Similarly, the locations of the biggest supercalderas also have obvious signs of volcanic activity. If you go to Yellowstone National Park, which is the location of the biggest known supercaldera, there is no doubt there is volcanic activity in the area. But there's nothing like this mentioned near the God's Eye at all. So, in all honesty, the volcano theory has a very hard time fitting the evidence that we have available for the God's Eye. However cool that idea might be, there are simply too many unprecedented requirements for me to conclude that this theory is the likely explanation. So, what other options are there? Honestly, I puzzled over this for some time until the next idea came to me, and that is the idea of meteorites. Now, I know there will probably be some armchair astronomers out there who want me to agonize over the difference between meteors, asteroids, and comets, so let me just simplify for the sake of this discussion and use the term impactor. Generally, impact craters can be categorized by two different types, simple and complex, with a primary observable difference being that complex craters have a central uplift in the middle. Now, of course, most impactors are so small that they don't leave any crater at all, and many of those that do leave a crater end up being the simple variety, but there are still examples of complex types to examine. The Earth Impact Database lists 190 known impactors that have collided with our Earth, and there are other impact sites that scientists still debate over today, because hey, who doesn't like grant money, right? So, I had this thought that if a complex impact crater filled up with water, leaving the central uplift as an island, then maybe we'd have our answer. As it turns out, it's not quite as easy as it sounds. The first thing I verified was whether there were any known impactors in our world that have left craters of this size, that is, 100 miles or more. And as it turns out, there are. The biggest impact crater that scientists generally agree upon is the Vredefort impact crater in South Africa. It measures about 300 kilometers or 186 miles across. So it's plenty large to compare to the God's Eye. I mean, the whole city of Johannesburg sits inside the crater, to give you a sense of how big this thing is. So, that's the good news. The bad news is, this impactor was estimated to have plowed itself into our planet around 2 billion years ago. Well, I guess you could say that's actually good news, seeing as how this thing was supposedly an asteroid that was 9 miles across, bigger than the impactor that struck near Yucatan in Mexico 66 million years ago, ending the Cretaceous period and causing the dinosaurs to go extinct. If some giant interstellar torpedo decided to ram the stern of the SS Earth today, the effects would be absolutely catastrophic to our modern way of life. Because either we all die, or we have to sit around watching Ben Affleck try to make sexy talk with animal crackers again. It's kind of a lose-lose scenario. But it is bad news in the sense that after 2 billion years, the observable features of the crater are severely eroded. Sure, geologists can look at it and tell us that it's there, but it's not really useful for what we're trying to accomplish. And this is just one example of a frustrating effort on my part to try to find useful impact craters to analyze. The next problem is that the majority of our Earth's surface is covered by water. So, statistically speaking, if we get hit, the impactor is likely to land in water instead of on land. And as it turns out, the composition of the impactor and its angle of impact also play major roles on how the impact crater is formed. The next big problem is that Earth went through several ice ages, the most recent one ending only 8,000 years ago. And the reason it's a problem is during these periods, the ice sheets that form over the Earth's surface are extremely heavy. And as they recede, they scour away the soil that lies underneath them, which again ruins the evidence of what I'm trying to find here. So what I really needed to find was a very recent impactor that did not strike water and that impacted an area that wasn't severely affected by ice ages. And that leads me to yet another problem. This is a picture of the most recent known impact crater of any significant size. It's called Karakul. It's located in Tajikistan, and it's one of the smallest complex craters at around 32 miles across, and it impacted around 5 million years ago, give or take. And you can kind of see the central island that I thought might be there, but the shape of the crater is very irregular, and for good reason. As you may be able to deduce from the picture, this impact crater landed in the Pamir Mountains, which border the Himalayas and are some of the highest mountains in the world. So the impact crater was limited by the hard rock of the mountains instead of landing in soft earth and expanding to its full potential. And on a similar note, other candidate impactors landed in sandy deserts or boggy areas, and their craters eroded very quickly. So what I really needed to find was a large, complex impactor crater, which didn't land in water, which was relatively young, which wasn't affected by ice ages or other major erosion, and which landed in appropriate soils to expand to its full potential size, but not erode too quickly. And as it turns out, there is an impactor that does match all of these criteria. It's called Mistastin Lake and is located in Labrador, Canada, and it looks like this. This is, by far, the best example I could find of a naturally occurring lake in our world that is similar to the God's Eye. And the God's Eye in many ways fits the same criteria as Mistastin Lake. It's not in a mountainous region, and it's not in a desert area or boggy area where its features would erode quickly. And in a world that experienced the long night, which appears to have at least some similar characteristics to ice ages in our world, the God's Eye is located relatively far south on the continent of Westeros. So if any glaciation did occur during the long night, the God's Eye was likely spared the worst of it, or maybe didn't experience it at all. So if we accept the impact crater theory, we can probably surmise a few things about the God's Eye just by observation. The first is that the crater is likely relatively young in the history of the world, as it appears to be relatively intact with little observable erosion of its features. The second is that the impactor likely struck the surface at an angle. Using craters from our world as an example, impactors that strike the surface directly tend to create craters that are very circular in shape. And the sharper the impact angle is, the more oval in shape the resulting impact crater becomes. And generally, the maps of Westeros that we have available show the God's Eye as a somewhat oval-shaped geographic feature, indicating that this is likely the case if the impactor theory is correct. And finally, we can make a pretty good guess at what the impactor was made out of as well. Generally, stuff that enters Earth's atmosphere from outer space tends to be made out of three broad categories: ice, stone, and metal, or some combination thereof. Typically, icy objects don't have a very long shelf life after entering our atmosphere. They melt away under friction with our atmospheric gases and end up becoming shooting stars, or the technical term meteors. Stony meteors tend to last longer in our atmosphere, as stone obviously has a much higher melting point than does ice. However, it is still difficult for a stony meteor to make it to the surface intact, typically because of the immense pressure the meteor encounters caused by friction and rapid heating as it makes its descent. Of course, there are a lot of other factors that play into this, like the structural integrity of the meteoroid, its metal content, its shape and angle of approach, relative speed, etc. There's a whole science to this that's well beyond what I care to put in this video. Probably the best known recent example of this is the Chelyabinsk meteor that made a quick trip through the atmosphere over Russia on February 15, 2013. Apparently, it was butthurt that Earth forgot about Valentine's Day and decided to break things up with us. So around 9:20 in the morning, it kicked in the door to our atmosphere going at a speed of around 42,000 miles an hour. Now, this event quickly became famous because it occurred over a relatively populated area. And modern Western society has a proliferation of smartphones, security cameras, and Russians who have lots of dash cams, apparently for recording crazy YouTube videos. And on this day, they would not be disappointed, because this meteor lit up brighter than the sun as it careened ever closer to Earth, intent on telling us just how bad of a boyfriend we've been, until it finally exploded at around 18 miles above the Earth's surface, releasing an explosive force around 25 times that of the atomic bomb dropped on Hiroshima. In case you haven't seen footage from this event, here's a quick clip of what it sounded like from the ground.
И сгорел там, да? Ну.
And that, ladies and gentlemen, is what I call a bad breakup. Of course, as soon as this happened, the area was flooded with scientists and treasure hunters hoping to pick up the pieces of this failed relationship, and of course, there were plenty of pieces to be had, including a few sizable meteorites, And after being analyzed, it turns out that this meteor was actually a fairly typical stony type, being comprised of about 10% iron with the rest being stony material. And this makes this meteorite very, very typical as far as meteorites go. Of the more than 50,000 known meteorites that have hit Earth, around 87% fall into this category. But on the other hand, because these stony meteors break up so easily, the fragments that do make it to the surface are far too small to cause the types of craters we're looking for. To accomplish this, we'd need something with much higher metal content in order to withstand the immense heat and pressure that it will encounter on its way down. And using the biggest impactors that have connected with Earth as a reference, we could estimate that the impactor that created the God's Eye would have had to have been around 6 miles in diameter, give or take, depending on its density and a bunch of other factors you'd have to build into the model. Now, by this point, I'm sure you're thinking, okay, cool, whatever, but what does this all mean, and why is it important to the Song of Ice and Fire? And these are all very valid questions that I intend to answer, but seeing as how this video is already quite lengthy, I'm going to turn this into a two-part series, so stay tuned for the sequel video, which will continue our discussion of meteorites, particularly metallic meteorites, as well as the God's Eye, and House Dane, and their ancestral sword Dawn. Thank you for watching, and be sure to leave your thoughts in the comments below.